So this is means row 1 and column 0. So this is just the position. And we are also getting another position. It's going to be the home position. It's going to be row 2 and column 3. So this is going to be the home position. We are going to calculate what's going to be the minimum cost from the robot start position to the home position. So basically, this line is one of the possible result. Yeah, so we can go down and we can go to the right. But how can we accumulate all those costs? It is inside of the row and column costs. So first of all, if this robot goes down, it means this is a row move. So yeah. So this means from the row 2 moves from row 1 moves to row 2. So where is the row 2? It is 3. It means we're gonna collect the value of 3. Now after that, we're gonna move to the right. So it means we have a column 1, we have a column 2, and we have a column 3, and until it goes to the home. Yeah. So what's gonna be the column? It's gonna be column 1, 2, 3. It's gonna be 2 plus 6 plus 7. It's gonna be 15. So 15 plus 3 is gonna be 18. This is gonna be the final result. But if this is a greedy solution, yes it is. We can improve it easily. So for this robot, it is here. But if this robot goes to this way and then go down and then go to the home, is this better? It is just the same idea. Because if this robot goes to right, it means we're gonna collect a value, column value of 2. Yeah, column 1, and then it goes down. Still, we're gonna have the row 2. It's gonna be 3, and then we're gonna have 6, 7. It's just the sequence is different, but anyway, it's gonna be the combination of those 4 values, 3, 2, 6, and 7. This means no matter what we went, we can go always like this. Yeah, we're gonna always go like as close as possible to the home, but we cannot go something like this. Definitely, this is not good. So yeah, because there are 2 points, this place and this place, definitely we want to go to a straight line instead of we go something like that. Definitely it is not good. So the greedy idea is also like this. Because all the value is positive, this means we're gonna always go to the straight to the home instead of making a return to somewhere else and then goes back. Yeah. Now, if we understand it's gonna be straight forward, we're gonna go from the start position to the home position. It is okay, but we don't know where gonna be the position of the start and home. So the start position is here. Maybe, let me use another color. So maybe the robot start position can be here, or maybe it can be here, or maybe it can be here. We don't know because the grid can be really big. Maybe it is this big. Yeah. So this means even we want to calculate the sum of the values like the row cost and column cost, we have to check where is the robot and where is the home, and which position is bigger. So maybe the robot is at the left side of the home. It is okay. We can calculate the sum of the values. Maybe it is at the right side. We can calculate the sum of this values, and similarly for the column. Yeah. So this is the basic idea. If it is the robot is up, it is okay. We just need to calculate this value too. But if it is down, we need to calculate all those values, including this row too. Yeah. So this is the basic idea. Now we're going to use this idea to solve the problem. Yeah. It is just a little bit coding because we don't know where going to be the position of the robot, where going to be the position of the home. So definitely there are going to be 4 different positions. So this is the home. Robot can be here, 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 or here. Yeah. So let's just start coding. So I'm going to prepare a start position. I'm going to call it start x because definitely inside a coordinate system it's going to be x and y, and start y going to be the start position. And yeah, similarly I'm going to prepare the home position. So home x and home y, it's going to be the home position. Yeah. And now I want to let me think about it. Yes, now I want to collect the values. Yeah, so I want to get the values. For example, I want to get the values of row sum and column sum. I'm going to prepare 2 variables. It's going to be the row sum and column sum. Basically, I want to calculate what it's going to be. Yeah, because definitely no matter where is the robot, definitely there's going to be the row sum and column sum. I just need to accumulate the values. Yeah, and finally I'm going to return the row sum and the column sum. But how can I calculate the row sum? So this is dependent on which value is bigger. So what happens for the row sum? So definitely this means the robot can go down. So this is a row sum. Yeah. So the condition is that if the robot y position as y start position is more than or equal to hy. Now I can calculate the row sum. Yeah. Else I'm going to calculate it because the robot is not up, it is at the bottom areas. Yeah, it is not at the top areas. I'm going to use another way. Yeah, but how can I calculate it? I just need to sum up all the values. I think it is straightforward. Yeah, and it's going to be inside of the row cost, and which value it is. Definitely, I will not include the sy. Yeah, because from row 1 to row 2, I will not include row 1. I only need to include row 2. Yeah, so this means it's going to be sy plus 1 to hy plus 1. Yeah, and you should be clear about it. Basically, this is a symmetric. If we know how to calculate the row sum, basically the column sum is going to be similar. Yeah. So else, if this sy is more than and equal to this hy, it means the robot is going to be at the bottom. So for example, this is row 3, and here I have a robot. It is at row 3. It is here. It needs to go up. Yeah. And but how can we calculate it? Yeah. It is similar. It is just the same sum of the row cost, and it's going to be yeah. So it's going to be starting from hy, because hy is smaller, but the sy will not include it. Yeah, because I'm at here. From 3 goes to 2, I only need to collect 2 instead of 3. So this is the definition. Now, if we understand how to calculate the row sum, basically the column sum is the same idea. We just need to copy and paste the code. And from here, we just need to change it to column and cost. And here, going to be the column cost. Yeah. And from here, we just need to change this one from sy to sx, and hy to hx. And here, similarly, we just need to change y to x. Yeah, because if we change it to x, basically it means the column sum. So this is exactly the column sum. Yeah, so this means for some problems, if it has the symmetric property, so for example, this is the home, and the robot has the symmetric property. So basically we can write the code, write one line of code like this. This is the first code, and then we're going to have the second code. It is symmetric, and then this one is also symmetric. This is also symmetric. Yeah, we just need to copy and paste the code. I'm not sure. Let me just run it to check if it works. Oh, it didn't. There must be something wrong with my coding. The second one is okay, but the first one is 0. Definitely it is not. Yeah, so it should be the row cost, and this is the sy, and hy. Yeah, this is a little bit strange, but it's okay. Let's just start decoding. Maybe something wrong. I forgot to change. I don't know. Oh, this is something I forgot to change. It should be sx and hx. Yeah, I forgot to change about those variables. Now let me just run it. Yeah, it is still the same. But it's okay. Let's just check the row sum first. So let me make a comment of this one, and I want to check the row I want to check the first example. So the row sum gonna be 3. This value gonna be 3. I want to check if it works. Yeah. So sy and hy, it's gonna be this is a 0 to 3, and this is a string. I think I did something wrong. It's gonna be the row 1 to 2. So this is gonna be the row sum. I did something wrong. It's gonna be sx here. Gonna be hx. Yeah, sometimes I make mistakes. I think you as well. But we need to just debug and find a way to fix it. So let me just run it. Column sum. So let me just define the column sum as 0. So the column sum is gonna be 0. So let me just run it. Yeah. So now it is still 0. This is a string. It should be less than or equal. So the sx should be less than or equal to hx instead of more than or equal. I did something wrong, I think. Now let me check. Yeah, now at least we have a 3. This means my coding should be okay because I included this value. Because I found the problem, I did something wrong. Yeah, because this is from 0 to 2 and 0 to 3. Normally this is going to be 0 because sometimes it happens, because for our problem this is a row 0, this is a row 2. Yeah, so for me I think this is a row 0, this is row 2. Actually it is not. Yeah. Now let me just uncomment and check if it works. So this is going to be y, and here going to be less than or equal. Similarly for this y, because it is a symmetric. Yeah. Now let me just run it. Yeah, as you can see now it works. And now let me just submit it. Yeah, even if it's asymmetric, we have to be careful about it. As you can see, it works and it's pretty fast. And what about the time complexity? Yeah, so as you can see, the time complexity is just dependent on the row and column, the sum of the row and the sum of the column. So let's just check. So it's going to be m plus n, and m and n going to be 10 to the power 4. That is why it's so fast. So the time complexity is going to be O m plus n. I think that's all about it. Thanks for watching. See you next time.